Hello students, how are you? The answer I am waiting is that you are doing good, right? So welcome back. So in this part, we will discuss about deviation from ideal gas behavior. How my real gas is deviating from your ideal gas phenomenon or ideal gas behavior. So in this part, we will be learning about interesting parts like you will be learning about your compressibility factor or Z factor. So why to waste time, students? Let's start with this part. Deviations from your ideal gas behavior. So we know that real gases deviate from your ideal gas behavior. That means they deviate from your ideal gas equation. They don't follow your ideal gas equation. So let's see. First, let's start with the compressibility factor. So compressibility factor gives you an idea how much extent your real gas deviates from your ideal gas behavior. So have you now tried to recall your Z plot? Have you recalled, guys? Z plot gives you an idea between your Z and pressure. What is Z? Z is a compressibility factor. So in this graph you can see that there is a Z on y-axis and there is pressure on the x-axis. So you can see any gas, for example consider hydrogen. For hydrogen you will get this kind of line. So what is happening? As the pressure increases, the value of Z keeps on increasing. That means the value of Z is moving away from the 1. That means the value of a Z is away from the ideal behavior or ideal value, which is 1. So what is Z plot? Z plot gives you an idea about the behavior of the real gases, how real gases behave with pressure. So Z is nothing but the compressibility factor, which is nothing but P into, what is P here? P is the pressure, V is nothing but V is the volume occupied by the gas divided by R, which is a universal gas constant, and T is the temperature. So Z is the compressibility factor. So Z should be 1 at all conditions for an ideal gas. What does that mean at all conditions? At any temperature, any pressure, my Z value should be 1, and if it will be 1 at any condition, this will be my ideal gas. Now for real gases, what happens? Obviously for real gases your Z value will be either greater than 1 or less than 1. That means Z value will not be equal to 1. So for real gases Z value will not be equal to 1. So what is now happening again? Z is nothing but volume occupied by any gas at any condition by volume occupied by the gas at an ideal condition. What is volume occupied by gas at ideal condition? It is nothing but RT by P. What is P? P is the pressure, T is the temperature of the ideal conditions. So Z can also be written as Vm by Vm at ideal. So implications. Can you think of certain implications about my compressibility factor by scrutinizing this graph? What are the implications? Think for a few seconds. Think for a few seconds what exactly your compressibility factor is giving you an idea about. If you just scrutinize deeply, you will understand the following implications. So at high pressure, what is happening at higher pressure? You can see that at higher pressures what is happening? Your gas is deviating largely from your real gas behavior. At higher gases, what is happening? Your volume occupied is very high compared to the volume occupied at ideal conditions, and your Z value is greater than 1, right? Since Z is what? That is Vm by Vm at ID. Vm by Vm ID. What is ID? ID is the ideal condition. So at higher pressures, Z value is greater than 1. And what is happening at these pressures. I mean, you can also say there is another point. At higher pressure, what is happening is your repulsive forces between the gas molecules becoming dominant, right? So you can use, right, you might be already knowing the graph between potential energy and distance. If you remember that graph, you can understand that at higher pressures what is happening? The repulsive forces between your gas molecules are becoming dominant because you are applying higher pressures for the gas molecules. When you are applying higher pressures for the gas molecules, the repulsive forces between these gas molecules becomes dominant. Now, at intermediate pressures, what is happening? You can see this is an intermediate pressure. This is an intermediate pressure. So, at intermediate pressures, what is happening? Your Z value is less than 1. At higher pressure, your Z value is greater than 1. At intermediate pressures, your Z value is less than 1. So, what is that happening? What does that mean? That now your attractive forces are becoming dominant. Your attractive forces are coming into the picture. That means between these gas molecules, between these real gas molecules, there are now attractive forces which are playing a very important role, right? That means more significant, this is more significant gases with significant IMF. What does that mean? IMF means intermolecular force. So at intermediate P or intermediate pressure, my compressibility factor is less than 1. That means attractive forces are becoming dominant. So what can you understand based on the above concepts? We can understand that a gas which obeys the gas laws, that is, what is that gas laws? What is that equation which all the gases obey? That is nothing but ideal gas equation, PV is equal to nRT. So from the first point we can say that a gas which obeys the gas laws or the gas equation PV is equal to nRT, strictly, remember guys, strictly at all temperatures and pressures. It might be at any temperature, it might be at any pressure, then that gas is said to be an ideal gas. Very important point, second point. The molecules of the ideal gas are assumed to be volumeless. So just remember the kinetic theory of gases. In kinetic theory of gases, we have approximated that the volume of the gas molecules is negligible to the volume of the container. What does that mean? It means that the ideal gas volume is, the volume of the ideal gas molecule is considered to be 0. And what is the other approximation we have taken when we are discussing kinetic theory? We have discussed also that there are no attractive forces between one another. The attractive forces between the gas molecules is negligible. That's why the pressure is because of the collision with the container, right? So these are the two important points we have already discussed when we are discussing about your kinetic theory of gas. But remember, no gas in this universe is ideal. That means every gas is real. So no real gas strictly obeys this equation at all temperatures and pressures. That means PV is equal to nRT is not obeyed by any gas in this universe. That means all the gases are real. So deviations from the ideal behavior are observed particularly at high pressures or low temperatures. So we have seen in the previous graph that at what temperatures and pressures? You can see at high pressures. These are the high pressures, right? These are the high pressures where your deviation is observed. So deviation from ideal behavior observed at particularly high pressures or low temperatures. So at low temperatures also you can say that your deviation from ideal behavior is taking place. Next important concept. So what is Z again? Z is nothing but it gives you an idea how much extent your ideal behavior is deviated. How much extent a gas is deviated from its ideal behavior. That extent is given by the concept of your compressibility factor Z. So the deviation from ideal behavior is expressed by introducing Z, which is the compressibility factor, and Z is nothing but PV by nRT. So for ideal gases, your Z value will be 1 and PV is equal to nRT. For real gas, PV is not equal to nRT, that means Z value is not equal to 1. So for real gases, you have two assumptions or two values of Z. One is Z less than 1 and one is Z greater than 1. So when Z is less than 1, it is negative deviation. And what does that shows? It shows that your gas is more compressible than expected from ideal behavior. Hi friends, so for any further doubts, you can open askIITians.com and you can find the discussion board, and if you click on it, you will get Ask Experts on the right side of the screen, and you select the category accordingly and you can post your question here. We experts at askIITians will be reverting you back within 24 to 48 hours. So students, in this part we have discussed about your Z plots, how Z plots gives you an idea about your information regarding your real gases. So stay tuned to our sessions. Goodbye. Take care.